In this episode we're going to be looking at a 1980s Fidelity CB 2000 FM. Let's see if we can make it look a little bit nicer. Hello and welcome to this episode of Microchips. Today we're going to be looking at this Fidelity CB 2000 FM. It looks a little bit dirty and a little bit worse for wear at the moment. As you can see, the top lid got some rust on it, but inside it's looking pretty good up to now. There has been a little bit of work done here and there, but nothing too major. So I'm quite happy with that. Let's have a look at the underside. No surprise boards this time. Everything looks nice and factory. Everything looks nice and clean. This was actually bought as working, so I'm expecting this to work. Maybe there will be some small issues, but it is a runner. Everything looks good, everything looks pretty well untouched, so happy with that. So let's get the front off. Now to get the front off, we're going to have to remove the microphone socket because it has a front facing microphone socket. And to do this, we're going to have to cut the wires. And there we have it, the wires are cut, the front is off. So let's get to restoring this front. Now, as with all radios with this metal fascia on them, like the CBXs and the 5 stars, over time the glue has failed and basically it just turns to dust. So we managed to remove one part, and let's just try and get rid of some of this horrible old glue. As you can see, it just turns to dust. So my old favourite, the old foam cleaner and a paintbrush, and let's give it a really good cleaning. A cotton bud to get into the hard to reach places. I think it's looking better already. Let's try and get rid of as much of this old glue as possible. Now, the front metal work. Now we need to be nice and careful with this because we don't want to be bending it or anything like that, because that would then ruin this. So again, a bit of foam cleaner. A brush, just working in, getting rid of the grime. It turns out quite nice. So let's see if we can get rid of any of this old glue off the back. I don't want to stress this piece of metal too much. So being very careful with the scraping tool, I am actually able to scrape away this old glue. I think it is necessary because there's no point putting new glue onto this old glue. Hopefully it'll stay on there for another 40 years. But as you can see, this glue has expired and turned into this yellow dust. Yeah, that seems to be most of it off. I'll rub down with some ISO. Yeah, our front panel's looking better already. And there I've added some B7000 to the front fascia. We'll carefully put it into place. Anything that spills out from the outsides can easily be wiped off. But hopefully I've put it on in such a way that it shouldn't do that. Right, let's get it back on the radio. And of course, once we get it back on, we've got the fiddly job of resoldering the microphone connector. Like always, a quick clean of the buttons in some foam cleaner. There, looks better already. Got a little bit of a shine to it now, which is nice. Okay, let's power this on. And it seems our signal meter bulb is a bit... There we go. So that's going to need replacing. That can easily be done. Let's make sure this is on frequency. 6011. It's good enough. And 991. Excellent. Bang on. Happy with that. So, let's fit some midband to this. So again, the front has to come off. And we're going to be using the tone switch for this. So as you can see, the tone is just a capacitor in the audio circuit that just cuts out the high frequency. And we'll just tuck the wires away into the loom. We'll remove the capacitor off the back of the switch. Now we have one clean switch. Just as preventative maintenance, we'll put a bit of switch cleaner in there. So the contacts are nice and clean. Now let's fix our signal meter lamp. So we need to fish the old light out of the meter. Now there is a resistor on the board there, but we won't need that resistor. We'll fit another current limiting resistor in for our LED. We'll fit our new current limiting resistor into place. And of course, solder it in. Now carefully taking the signal meter apart, we can get to the place where the bulb is. Being careful not to damage the meter. So the bulb is quite well glued in. We'll keep one of the wires because we'll be needing that. Now as you can see, I've drilled two small holes in the side of the meter and fitted one of the LED cob lights in. And we're just going to secure it in place with a little bit of B7000. Now I've had to be very careful with this because you cannot bend these LED lights in any way. Now these lights provide a nice uniform light across the back of the meter. Instead of it just being one spot like you find with normal LEDs. So I'll solder it into place. This should provide a nice illumination. we'll solder the other lead to the board, to our new current limiting resistor. Let's try it. Now the camera makes it brighter than what it is, but when it's in the radio it provides a nice bright backlit meter. So let's prepare the area for our mid-band modification. We have to move a couple of components to the back of the board, one of them being this inductor. This is because of the size of the IC pin header, and we have to put this resistor on the back of the board as well. Now let's take out our PLL IC. My nice desoldering gun makes short work of removing this. Makes a nice tidy job as well. And we'll remove the IC from the radio. Now we're just going to weigh up the size of the ribbon and place the pin header on the end of the ribbon. I've already shown how to make the pin header, so I won't bother doing that again. And then we'll solder the pin header into place. Here's our band switch wired up. And let's place the PLLs onto the modification board. Just leveling out any solder that's on the pins. That's our first PLL into place. We'll place our mid-band PLL in the correct socket. Right, let's do some frequency tests. And align our VCO as well. Give me that 27600 for channel 1. 27990 for channel 40, so not too far off. Seems to be working nicely. Right, let's try mid-band. And the VCO voltage seems to be a little bit low, so I don't think that's going to lock. Seems to lock okay on 40, just not on 1, as expected. So that can easily be adjusted. So just adjusting our transmit VCO there. Yeah, that all seems to be good. Now we just need to adjust the transmit power now. It seems to be a little bit low, as always, on the bottom end of mid-band. So using my oscilloscope and trimming tools, I managed to get the transmit kind of level across the band. It's a little bit fiddly getting the VCO interlock everywhere across both bands, but as soon as you've done it, it's fine. Now what I'm actually fitting here is a prototype of a board that I've had made, and this board is actually in the Bindite Express 2 book. Basically it's just a transistor switching in a couple of capacitors on one certain band. So we're actually going to see if this actually works and see whether we can get our frequencies as close as possible on both of the bands. So we need to solder one lead to a crystal, we need to solder a permanent 13 volt supply, we need to solder a ground, and then we need to solder to the band switch to activate it on the band that we want to compensate, and that needs to be activated with 13 volts. I will be doing a video about this very soon, but this was just a quick mock-up on some Vero board just to see whether it would actually work. Okay, let's do some frequency tests. .964 seems to be okay. 4049 seems to be okay. UKFM seems to be a little bit low. Yep, UKFM is running a bit low there, so let's see whether we can adjust it. Now at this point I'd found that it wasn't moving the frequency as much as I'd wanted it to, so I was just experimenting with a variable capacitor in place of one of the fixed capacitors on this board. See whether we could actually, between the two variable capacitors, actually get a happy medium. And I think we've done quite well. 6007, close enough. Try channel 40, 9907, tiny bit low. 405, bang on. .965, bang on. So let's have a look at this cabinet, see if we can do anything with that. So first off, we need to get rid of this sticky tape. Now I've actually decided that I'm going to try and respray this cabinet. But first off, we'll give it a clean anyway. Bottom doesn't look too bad, but if we're going to respray it, we're going to have to do both anyway. Okay, let's give it an air test. All our segments seem to be fully operational as well, which is nice. Don't have to worry about cleaning the band select switch.
Yeah, he's alright. Yeah, he's kept himself busy.
So there we have our Fidelity CB 2000. Looking a lot better than what it did, and performing just as good as it should do. I know it's got some age related wear and tear, but that can't be helped. But I think all in all, it's actually turned out quite nice. Now in the next video, we're going to be attempting to spray the case. See if we can make that look any better. So anyway, if you enjoyed this video, don't forget to like, subscribe. Thanks for watching, and see you in the next video.